So right now you are entering the computer science and engineering department. So now you can say that you are, yes, good evening. You can say that you are the computer science and engineering department. Okay. So my name is Handique. Okay. So just this particular semester, I will teach you that particular subject, digital elect. Code is CSE-303. So earlier its code name is something. Now some syllabus will be changed. Okay. So now code name also changed. The subject code is CSE-303. Okay. And subject name is digital electronics. So can you tell me which one is your class representative? Who is the class representative?
Yes, sir.
Who is the class representative? Are you getting
Yes,
my
sir.
point?
Raj, sir.
Who is the class representative of third semester?
Raj, sir.
Pardon? Raj.
Raj.
Okay, okay. So Raj, you are present here? Okay, Raj Basfar,
yes.
na?
Yes,
Okay,
sir.
okay, very good, very good. See, you just, I am providing the timetable to you, and from the notice board also you can get the timetable. Okay.
Okay.
So from the timetable you manage all the subjects, whatever the class, it will start on time. Okay, according to the class timetable. So hopefully Wednesday class will be started from 10 to 11. Okay, but sometimes what happen, I will take the class earlier, before 1 hour. That means what? 9 to 11, some particular cases, I will start my class 9 a.m. to 11 a.m. I'm talking about only Wednesday. Tuesday, we are starting from 9 to 11. Okay. This particular introductory class, actually, what is the structure of this particular subject, this particular course? Okay. And what is the evaluation process? Okay, and what is the basic requirements, basic things are required to complete this particular course? That particular part today we will discuss. Okay, and I'm telling you one thing. This particular digital electronics is very important, very important subject, not only for computer science and engineering department. Okay, computer science and engineering stream. It is also required in electronics, information technology stream, and as well as electrical stream. Okay. So because we are developing some type of logic type of things. Okay. So this basically what happened, this type of subject is belongs to the hardware field. Okay. But you don't worry because this is the core subject. Okay. And when you are going to the 8th semester, 6th semester, 7th semester, whatever the semester, this particular concept is required. So I will try my best to learn everything to you, okay, according to the syllabus. And if any doubt, all of you, I'm requesting you, when my class is going on, that time you just switch off your microphone so that the unnecessary noise are not coming. And whenever you are facing any doubt, that time what happen? You on your microphone and ask me. Okay, it is no problem. And so directly, without wasting our time, directly I'm going to that particular subject, and some particular important, because sorry, I have no WhatsApp number. I have a WhatsApp number, but I'm not using WhatsApp number. So any communication we are making, it is only through by mail. Okay, formally I'm sending to mail, and you don't worry, everything is on systematic. Okay. So just I'm starting the class. Okay. So just and you tell me if the slide is PPT is not coming, then you just tell me, sir, PPT is not visible. Then I will try. Okay. Yes, PPT is visible.
Yes, sir.
PPT is visible or not?
Yes, sir.
Hello.
Visible, sir.
Okay.
Visual, sir, visual.
Okay. So see here, the subject name is CSE-303 and the subject code is CSE-303 and subject name is digital electronics. Okay. And today we are discussing some introduction of this particular subject. Okay. And this is the core subject. Okay. And yes, any doubt?
Visible, sir.
Please pardon. I am sorry. Yes, please tell me if you have any doubt. Okay. PPT is visible or not? Please say something. Hello.
It's
Yes,
visible,
sir, it
sir.
is visible.
Okay. Okay. So this is the introduction of this particular subject. Okay. So what is the objective of this particular subject? Okay. So objective of this particular course. To see here, the first point is just a minute. Yes, just a minute. So the objective of this particular subject. So at first we are discussing about some particular part of digital system. That means why digital system, what is exactly mean of digital system. After that, what happened? We are directly going to some particular number systems and why number system concept is coming in digital system or you can say digital circuit. And after that, what happened? We are going to some particular Boolean algebra. Just a minute, so much. Okay, so we are going to the numbering system. And after numbering system, we are discussing about the Boolean algebra. So why it is Boolean algebra? Actually, when we are designing some particular digital circuit, why Boolean algebra concept is coming. Okay. And to perform the Boolean algebra, we have required some particular operation. And that particular operation we can use in digital system, that is called a logic gates. Okay. So why we are using logic gates? Logic gates is nothing but some type of special type of operation, and gate means what? That particular gate keywords we are using in digital system. Are you getting my point? Hello?
Yes, sir.
Everyone listen, na?
Yes, sir.
Okay.
Yes, sir, yes, sir.
Okay. So next point of this particular course, learn about when we are designing the digital system, before some particular process is required. Okay. So what happened? Every circuit there are some standard particular function. So what happened? So when we are designing some particular digital circuit, that time what happened? You have some particular process is required. Okay, systematic process is required. Or that particular systematic process, we are required some particular mathematical model or mathematical expression. Okay, to know the behavior of that particular mathematical representation, we require some type of Boolean function, that is called a Boolean function. But remember, when we are going to implement the Boolean function, there are three particular steps are required. So at first one is called how we are representing the Boolean function. After that, when we are representing the Boolean function, how we can manipulate that particular Boolean function. Are you getting my point? And when we are manipulating the Boolean function, that time what happened? Is it that means can we minimize that particular Boolean function? Because what happened? Based on the Boolean function, actually your circuit will be designed. Okay, so some type of minimization process is required. Okay, this is the second step. And the third step is that we are, after knowing this particular 2 points, then we are directly go to the designing of two circuits. Okay, so basically digital circuits based on two type of circuits. One is called a combinational circuit, one is called a sequential circuit. We are going details later on what is exactly combinational circuit and what is sequential circuit. But for the for the point of time, for the time being, you just remember that combinational circuit is only the output is always depend on the present input. But when we are talking about the sequential circuit also requires the present input, but one additional features is required, that is called a memory. So past information also implemented in sequential circuit. So there are different type of designing techniques are there in combinational circuit and sequential circuit. But remember one thing, you cannot directly go to the sequential circuit. You know the concept of combinational circuit, then you can design the sequential circuit. Why it is so? Because what happens, sequential circuit is the combination of combinational circuit, also memory circuit. Some type of memory components are required. Okay. So when we are designing the sequential circuit, that time what happens, some type of concepts are required. That is called a finite state machine. So how we are designing the state? State means what? Some particular standard input, we are going one particular state to the another particular state. So how this particular moment is established between the state? Okay. So what happens based on the state, actually what happens, digital circuit or whatever, the information is passed one particular component to the another particular component. So for a particular time being, my state is X. So after some particular inputs are entered, so that time what happen? Some other it is transferred to the another components. So another component means what? It is going to the next state. So when we are designing the sequential circuit, that time what happen? Finite state machines also concept is also required. And maybe sometimes what happens, so when designing the state machines, that time what happen, your state machine is something bigger and someone state machine is some smaller than the other one. So what is the exact minimization process? So that is called a state minimization. And when we are doing the designing the finite state machine and state minimization, we are using some particular algorithmic structure. We are using the algorithmic concept. That particular algorithmic concept is called a state machine. Okay. So please try to maintain the time. Okay, otherwise, because this one is the online class, if you want to join this particular class, again, I am some particular disturb is coming, some particular noise is coming, again, I am going to that particular moment. So, so try to attend the before 5 minutes or before 2 minutes. Okay. Okay. Any doubt? Any doubt?
No, sir.
Okay. So, so I am not getting, that means all students are present or not. But remember one thing, it is better you can start from the initial initial point of view. Okay. So be serious during the class, and to maintain the, that means if you are any doubt, then please ask me and everything, because the verbal communication is very important. Okay. So don't keep silence. If any doubt, then please ask me. Okay, don't hesitate. And I don't know all the peoples are present or not, but because it is now up to you, because maybe you are on the screen, but you are not physically present. Okay, so please don't do that, because every particular concept is because digital circuit is what, if your one particular concept is not clear, then again what happen, next step you cannot understand. Okay, so it is one type of step by step we can increase. Now we are going to the actual concept. Okay, now next thing is that when the last point is that when we are clear all the 4 points, that time what happen, we are going to the designing the asynchronous circuit. Okay, how to analysis and how to synthetics means what, we are designing the asynchronous circuit. Are you getting my point? And please remember, it is better you can in front of you, you can keep your copy and pen. Okay, these type of things are sometimes what happen, some particular point is very important. So when you are study you own that time, what happen? These particular points are give some particular hints to you. Okay, and remember one thing. I'm just giving the lecture, and I'm clearing the your concept. But one thing is always remember, you can study through the book. Okay. So when we are doing the self-study, that time what happen? You can use your book, the standard book. I'm talking about the textbook. Okay. And I'm not giving, because this is the conceptual subject. It is not some type of theoretical subject and some type of things. So what happen? Just I'm clearing the every concept, and after that what happen? You can design, you can study yourself. Okay. So self-study is very much important for this particular subject. Okay. All of your microphone is Abhijit Singh. Abhijit Singh.
Yes,
Why
sir.
you are off your microphone? Abhijit Singh.
Yes, sir.
Okay, okay. Alimuddin. Who is Alimuddin? Please be on your video. Okay. Arijit Das. On your microphone or on your video and microphone. Okay. So you are Arijit Das. Joydeep Roy, please on your microphone. Okay. Kapil Dev Kumar. Kapil Dev Kumar. Who is Kapil Dev Kumar? Are you present there? Kapil Dev Kumar?
Yes, sir.
Okay, okay. Who is real? Who is real? R-E-A-L. Who is real? Please on your microphone and video. R-E-A-L. I don't know his name or her name. Who is real? Sanghamitra Deuri. Sanghamitra Deuri. Sanghamitra Deuri is not present?
Yes, sir.
Okay. So, Tripti Nayak. Tripti Nayak. I am randomly choose. Okay, just I'm checking for checking purpose. I'm using this particular one. Tripti Nayak.
Yes, sir.
Okay. So your the PPT is clear, visible to all of you.
Yes, sir.
Yes, sir.
PPT is visible to all of you.
Yes, sir.
And I am kindly requesting all of you, if you any doubt, then please ask me.
Okay.
Okay. Don't hesitate. Don't hesitate. I am again repeating. Don't hesitate. Tama Roy. Tama Roy. Tama Roy is present. Okay. Raj Buffer. Okay. Okay. Then again, I am going to the PPT. Okay. Please off your microphone and off your video, because here some particular, because I am using my own network. Okay. Maybe bandwidth may be slow. So please off your microphone and video. And if any doubt, then please ask me. Okay. Screen is visible, PPT is visible?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay. So this is the, this particular one is the objective of this particular course. Okay. So at first we are discussing about what is exactly digital system. Okay. So any other systems apart from the digital system? Okay, so why numbering system is required in digital system? And when we are talking about the numbering system, again, some particular concept is required, that is called a boolean.
Sir, PPT not visible, sir.
PPT is not visible.
Sir, PPT is not visible.
Visible.
Okay. Wait for a few minutes. Okay.
Visible, yeah.
Visible, sir.
Visual.
It is visible,
Visual.
but someone is saying
No,
that
sir,
it is
no,
not
sir.
visible.
Yes, sir, we can see that.
Visible, sir. It is
Sir,
visible,
no
sir.
visual, sir.
पिन करना पिन कर दो.
Okay,
Sir,
then
no visual, sir.
just a minute. Someone have some particular problem. Okay. Just a minute. Now it is visible.
Yes.
Sir, visible,
Yes,
visible,
sir.
sir.
Okay. So what happened? Again, we are discussing the representation. That means of representation, manipulation, and minimization of Boolean function. And after that, we are going to the design of combinational sequential circuit. And I have already discussed that means when we are going to sequential circuit, some type of concept is required. That is called a finite state machine. How to minimize that particular state machine, and some particular algorithmic procedure is required to minimize or designing the state machine. After complete this particular portion, we are going to design how to synthetic design of a synchronous circuit. Okay, how to analysis and design the synchronous circuit. Okay, that is the objective of this particular course. Now what is the outcome of this particular course? Outcome means what? You learn about the concept of digital system, but and when we are going to the upper semester, suppose computer network communication, or some type of algorithmic, some type of suppose you are some type of cryptography type of things, any type of algorithmic designing the algorithm and all those things, that type of whatever, this particular logic concept is always required. Okay, so it is not like that this particular points only required in digital electronics. Many particular field we can use. Okay. So, and also if your career point of view, when you are appearing some particular gate or some particular competitive exam, that time also this is the very core subject. Digital electronics is very core subject. Okay, and some particular university and some particular institute, instead of digital electronics, they are using some type of different names. Suppose switching circuit and logic design. That is also similar to the digital electronics. Just they are changing the name. Okay, some particular logic design and circuits, some particular institute and university also they are using this particular name. Okay, so in our school, that means we are using this particular name. So the course name is digital electronics, but all are similar. Okay. So just write down this particular textbook. If you are not getting the syllabus, then please write down this particular textbook and reference book. So first two particular textbooks are very important. And now I don't know, maybe Maurice Meno, one particular the book name is Digital Design, and writer is Maurice Meno. It is very famous book. It is that means all the students all over the world, this particular book is using for academic purpose. And I don't know, right now it is maybe 6th or 8th edition, but generally I'm using the 4th edition. Okay, so this particular book you are getting from the library, departmental library also and central library also, and it is better you can buy this particular book. Flipkart and Amazon, these particular books are available. Okay, this particular book or different type of edition books are available. Next one, you can also get this particular book maybe from the department library, I don't know, but you can get the central library. Okay, the book name is Fundamental of Digital Circuits, 4th edition, and the writer name is Anand Kumar. Okay, published by PHI. And some particular topic, the reference books are required. Okay, so see here when we are discussing some type of logic families or different type of logic families of digital circuit, there are different type of logic families are there. Some particular books are very good. Okay, so for that particular purpose, some topics you can I'll tell you, that means in which particular topic is good for this particular reference book. That means using this particular reference book. So one particular reference book is Modern Digital Electronics. I have a 4th edition, so you can use the upper edition also. The writer name is R.P. Jain, and it is Thomson TMH. Okay, and the next one is Switching and Finite Automata Theory. So when we are discussing the finite state, when we will discuss the finite state machine or minimization the state machine, this particular book is helpful that means helpful. Okay, the book name is Switching and Finite Automata Theory, and I'm using the 3rd edition. You can use the 3rd edition, is available. Okay. So any doubt, any clarification from your side? Any clarification from your side?
No doubt, sir.
So please write down the book. Please write down the book, because after that I'm not discussing about the books. Okay, and not maybe when I'm providing some particular material, don't expect me I'm providing these particular books. So it is better you can write this particular book. Okay, and don't using the mobile flipchart and all those things. Thus you maintain the formal like formal student, you can write down on your copy. Okay, don't use the shortcut. Okay, so this particular textbook and reference book is enough to complete this particular course. Okay, so can I move the next slide?
Yes, sir.
Okay, now I'm going to the evaluation process, and this one is very important, all of you. You see, generally what happened, I don't know what about the first year of you. Okay, but in our department we are using the marks are distributed like this. The first one is called internal exams, second one is called a mid-semester exam, third one is called a end semester exam. So mid-semester exam and end semester exam, it is not my hand, and this particular exam is controlled by the exam branch. Okay, but internal exam, out of 100, total mark is 100, the 20 marks is coming from the internal exams. Why I am writing internal exams? Because I will conduct 3 internal exams. Right now I am not deciding, out of 3 I am considering best of 2 or the 3 is compulsory. No, 3 exams are compulsory. That particular part I will inform you later. Okay, so from the internal exam, it is coming from 20 marks, mid-semester exam it is coming from 30 marks, and semester exam it is coming from 50 marks. Total is what? 100. But this one, there are 3 internal exams. This particular part is very important. You can write down the date. The first internal exam will be conducted on 23rd 09/2020. Second internal, this particular date is fixed. If some particular special circumstance, some suppose medical background or some particular difficult reason, so that time what happen, I am cancel this particular internal exam of that particular student, of some particular student. But this particular, generally I am not changing the date. And this particular date you can check from the calendar. This particular all are the Wednesday. So first internal exam 23rd 09/2020, second internal exam 21/10/2020, third internal exam 25/11/2020. And I will conduct these particular exams on the timing according to the class timetable. And what types of structure of this particular exam? It is coming short type of question or multiple choice type of question or descriptive type of question. That particular part I will inform later, before 10 days or before 15 days or before 7 days. Okay, but this particular date is mandatory. You write down this particular date. All of you clear? Any doubt?
No, sir.
No, sir.
No, sir.
So if you have any query or any problem, then you can ask me, no problem. You don't hesitate. I'm telling you, and don't hesitate. So this particular date is very important for you. Okay, just write down this particular date, and based on that, I will conduct this particular exams. Okay.
Sir, what is the syllabus for
So yes. So see here,
Overall.
I am writing the last sentence. I am writing the detailed instruction will be informed later. Okay. So obviously what happened? Generally what happened? What I am doing? Suppose today I am conducting the class, and tomorrow you have a internal exam. So today's syllabus I am not including. Are you getting my point? So suppose what happened when we are going when we are reached 23rd 09, that time what happened, we are on unit 3 or unit 2. That means some particular part we are discussing on unit 2. Okay, so that particular part is not coming on 23rd. So that particular part also I will inform you later. Okay, you don't worry. Just you remember that dates. Any doubt?
No, sir.
Okay. Everything is clear up to this?
Yes, sir. Yes, sir.
Now quickly, because it is right now it is how many? It is 7:32. Just I am giving the small introduction, and your class will be started. Regular class will be started on Tuesday. That means sorry, not today is Monday. Yeah. Okay. So tomorrow you have a class.
Yes, sir, from 9 a.m.
Okay. Good. Very good.
Tomorrow, then Wednesday.
Just tomorrow that means tomorrow the regular class will be. Just I am giving some particular introduction. Okay. So now what is electronic circuit? Okay, because digital circuit also one type of electronic circuits. Okay, so electronic circuits and systems are two kinds. You heard about analog and digital. Are getting my point? So what happened? Now what is analog, then what is digital? You see, analog circuits are those in which voltage and currents vary continuously through the given range. Some particular range are there. Okay, suppose some particular range, maybe it is minus 5 volt to plus 5 volt, or minus 10 volt to the plus 10 volt. Okay, during that particular range, voltage and currents vary continuously. Okay, and based on that particular one, the analog circuit is actually works. Okay, some particular specific range are there. Suppose when we are talking about the minus 10 to plus 10 volt, that time what we can use 5.75 also valid that particular range, 2.75 also valid that particular range. Suppose 8.92 also valid that particular point, 9.75 also valid that particular voltage range. Okay, but remember one thing, if we are getting the proper output, that time what happened, exact that particular value is required. Suppose the output is required 9.75 voltage. If we are providing the 9.7, 4.5 or something, that is also work. The outputs are also coming. But what happened? Some particular noise are generated. Noise means what? Unwanted signal. So some particular disturbance are coming. Noise means what? Is unwanted signal. Okay. But analog circuit, we can some particular where we are using the analog circuit, suppose signal generators, radio frequency transmitters, receivers, power supplies, electronics motor, speed controller are the example of analog type instruments. Okay. Now there are some particular advantage and disadvantage of analog circuit. That particular part we are coming. Okay. Now this is the general properties of analog circuit. Now then, what is digital circuit? Digital circuit is one in which voltage level assume a finite number of distinct values. Now, when we are talking about the distinct values, that means what is a distinct values, or you can say that discrete values. Okay, so what happened? We are providing some particular specific value. Okay, and either if this particular output is coming, we can use this particular value, and this particular outputs are not generated. That time what happened? Some defined outputs are generated. That time what happened? These particular values are working. That means what? Always digital circuit working on discrete values, not depend on any particular some particular given range. Okay, so like analog circuit, we are using some particular range of the voltage -5 volt to the +5 volt. There are different type of numeric values are coming, different type of different values are coming between the -5 volt to the +5 volt in analog circuit. But this is not the case in digital circuit. Digital circuit means what? We can use some particular that means distinct some particular specific type of values we are using. What type of values are we are using? That particular part we'll discuss later, but you know, for a time being, we are using some particular binary values. Binary values means what? Either two binary values, one is 0 and one is called a 1. And 0, sometimes it is called a false and one is called a true. Sometimes 0 is called a low and 1 is called a high. So different type of keyword we are using. Okay. And based on these particular properties, digital circuit are often called a switching circuit. And someone is asking you, digital circuit is a switching circuit? Your answer is yes. Then why it is called a switching circuit? Because the voltage level in a digital circuit are assumed to be switched from one value to the another value instantaneously. Okay, so suddenly it is going to the one value to the another value. There are no transmission time is required to transfer one value to the another value. It is instantaneously it is changing. You cannot predict that particular change. Okay, it is going low to high, high to low, or vice versa. That means 0 to 1, 1 to 0. It is changing. So moving 1 to 0 or 0 to 1, that means one state to the another state, and one. Suppose 0 is the one state and 1 is the another state. So that means the transferring between the two states. So what when switch? So for this particular properties, digital circuit is called a switching circuits. You are keep silence. Please ask me any doubt. You are getting any doubt?
No, sir.
No, sir.
Don't
I have a question.
don't sleep. Don't sleep. Sleeping. Okay.
Yes, I have a question.
Yes. Very good. Ask me.
Sir, the values of digital circuits, are they in voltage or something, or they are just simply numbers having no voltage, ampere, anything?
No. Yes, you are asking very good question. So what happened to operating the digital circuit? Yes, we are using some particular numbers, but
Yes.
that particular numbers we are not saying the normal numbers. Suppose so whatever we are using the mathematics number, we are using the some particular that, but what happened? 0 and 1 is called a binary number. Okay, when we are talking about the digital circuit, 0 and 1 is called a binary number. Now you are coming to the next question, voltage. So what happened when we are producing 0 and when we are producing 1? That time obviously voltage is required. Are you getting my point? So how much produce is required? The voltage is required to produce that particular 0 numbers and that particular 1 numbers. It is something different. Okay, but what happened?
Okay, sir.
Yes, 0 and 1 obviously number, but 0 and 1 in this particular course, 0 and 1 is not a normal number. It is called a what? Binary number. And generating this particular number, obviously some particular voltage is required. Without voltage, it is not doable, because of what happened digital circuit. Suppose your laptop, suppose your mobile, you can switch on your, there is power supply is required. Okay, so when power supply is required, obviously current concept is coming. That means what? Voltage also it is concept is coming. Are you getting my point? Are you getting my point?
Yes, sir.
Yes, sir.
Okay. Any doubt? Any other question? Whatever I am discussing this particular.
Sir,
Yes, please.
sir,
Yes.
So then it means that 0 is change in voltage.
Yeah.
0 and 1 it means changing in voltage for the working of the circuit.
Yes, because what happened, I'm already telling you. That means what? So when some particular circuit, what happened, we are providing some particular input. Are you getting my point? And that particular input we are converting to the 0 and 1, because digital circuit always have a two specific range. One is called a 0 and one is called a 1. Are you getting my point? But when we are talking about the analog circuit, that means analog circuits are those in which voltage and currents vary continuously. Are you getting my point? Through the given range, some particular specific range we are providing. Okay, that is, suppose what happen, we are providing some particular range plus minus 5 volt to the plus 5 volt.
So we can't hear you, sir.
Yeah. Okay, are you hearing me?
So your
Yes,
voice.
Okay, so when we are talking about the analog circuit, that time what happen, we are some particular range we are providing minus 5 volt to the plus 5 volt, no, 5 volt. Are you getting my point? So that time what happened, 2.79 also within that particular range. 3.75 also within that, but there are different type of values are generated in analog circuit within that particular range. But this is not the case in digital circuit. Digital circuit we are using only two, that means what? Only two distinct values we are using, 0 and 1. Okay, and based on that particular input, that particular circuit actually works. Now what happened? How 0 and how converting 0 to, how we are converting 0 to 1 or 1 to 0, that is some particular different case. So that particular part we will discuss later. That's why some particular logic concept is required, gate operation is required. So how that particular values are sent, 0 moves to the 1 or 1 moves to the 0. So that is totally depend on the Boolean function, whatever the function you are providing, that particular circuit. So without function, you cannot design the circuits. Okay, some particular concept, some particular systematic procedure is required to design the analog circuit or digital circuit. Okay, but what happened? What is the properties to differentiate between the analog and digital? That is that particular part we will discuss. We are discussing. Okay. Any doubt? Your concept is clear? Your concept is clear?
Yes, sir. Yes, sir.
Okay.
Thank you.
Any doubt? Other one? Any other query? Any other query?
No, sir.
So remember, digital circuit are also called as switching circuits. Okay, this is also very important point. Next, digital circuit are also called logic circuits. Why it is called a logic circuits? Because each type of digital circuits obey certain set of logic rules. So what type of logic rules, and based on that particular logic rules, how we can design the digital circuit, that particular part we will discuss later. But you can remember, for the time being, you can remember that when we are designing or when we are implementing some particular logic circuit, that time what happens, some particular logic concept is required. And logic concept is made or obeys a certain set of logic rules. What are the logic rules? That particular part we'll discuss for coming session. Okay, so coming that means that particular part we'll discuss. Okay, you don't worry. And where we are using the digital, everywhere these days, everywhere we are using the digital systems. Okay, some computation and data processing also we are using. So to tell you, that means it is huge field, control systems, communications and measurement. And there are different type of fields we are using the digital system. But digital system these days, the digital system is very popular as compared to the analog system. Okay, but we'll discuss later. Some particular cases are there where the analog, what is the limitation of digital system, that particular part we are going to discuss. Okay, next is that some particular advantages of digital systems. So the first advantage is that digital systems are easier to design. Why it is easier to design? Because this particular digital circuit there are only two voltage level. Okay, so now someone is asking the voltage. That means it is, we are voltage level, we are representing as a number. That particular number is called a binary number. What is 0 and 1? Okay, so 0 and 1 is one type of voltage level of that particular number. Okay, so why it is easier to design? Because in digital circuit there are two voltage level. One is called a high and one is called a low. High you can consider it as a 1 and low you can consider it as a 0. Okay, so based of, due to we are considering only two voltage level, that time what happen, our implementation we are getting the exact numerical values of voltage. In analog circuit we are getting 2.87 or we are getting 2.31. Okay, but we are generating the output. Okay, but that is not an accurate output. But in digital system, we are using two voltage level 0 and 1. For that particular purpose, what happen? Our designing is very easy. Okay, so because we are playing with the two voltage level, high and low. That time what happen? So our that means our designing concept is not a too much complex. Okay, so when we are compared to the analog system or analog circuit, that time what happen, digital system are easier to design. That is the main important. And next point is the information storage is easy. Why? There are many types of semiconductor and magnetic memories of large capacity, which can store the data very easily. Okay, that is the beauty of digital circuit. So whatever we are using the different type of components, suppose memory, some type of different semiconductors. So huge type of semiconductors or memory we can use in digital system. So whatever we can easily store the information. Now next advantage is that accuracy and precision are greater. Precision means what? Accurate. Accuracy and accurate. Because why it is accurate? Why digital circuit is accurate? Because what happened? Again, the same concept is coming. We are getting the low and the high. The voltage level is low and high. There is no middle type of in between. If someone is asking you in digital circuit, there are any other voltage level which is lie between low and high? Your answer is no, because digital circuit only knows two levels, two voltage level. One is called a low and one is called a high. So for that particular reason, what happen? Accuracy and the exact result we can get from the digital circuit. So that is the accuracy and precision are greater. Now, digital systems are more versatile. Versatile meaning is that but adapt too many different functions. Okay. So what happen? Digital system itself is a different type of, that means components we are using. Okay. So maybe we are using some particular gates, different type of gates. Okay, the combination of gates or different type of flip-flops. So you don't worry what is a flip-flop, we'll discuss later. Different type of components we are using. So what happen? For that particular reason, so what happen? It is more different function we can accommodate, we can design one particular digital system. But when we are talking about the analog system, it is very difficult, because when we are introduce the different type of functions in analog circuit, that time what happens is circuit size is very large and the circuit also very complex. Okay, for that particular reason, digital system is good, and it is more comfortable as compared to the analog circuit. Also, digital circuit are less affected by noise. Now, what do you mean by noise? Noise means what? When we are producing the noise is also occurred in analog system also and digital system also. Okay. And now, what is the definition of noise? Noise means what? Unwanted signal. Those signals which is not required. Okay. So what happens? Digital circuit are less affected by noise. Why? Because see here, in analog circuit, suppose what happens? Accuracy is more meaningful to produce the accurate output. Suppose we require the output is the exact voltage level is required 2.97. But if you are getting the 2.21, that time what happened? Some particular extra noise are coming. Suppose instead of 2.97, we are getting 3.01. Some particular extra noise are generated. But this is not the case in digital circuit. Digital circuit also noise is generated, but less as compared to the very less as compared to the analog system, because we are operating two voltage level. One is high, one is low. Are you getting my point? Yes or no? All of you very silence.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. More digital circuit can be fabricated on IC. So what happened? We are using the different, because you heard about VLSI, very large integrated circuit. You are sometimes you heard that particular keyword. So what happened? Now what happened? Different type of IC we can incorporate it in a single particular board. So different type of IC chips we can accommodate when we are designing the digital circuit. But same thing when we are applying in analog circuit, that time what happened? The circuit is very complex. It is, and area wise it is very huge. Power consumption is more. I am talking about the analog circuit. But as compared to when we are using this small fabrication circuit is required, that means integrated circuits are there. Many integrated circuits are there. Okay, and the space is very less, and power dissipation also very low. Okay, so what happened? Fabrication process on IC is easier as compared to the analog system. So just I am highlighting this particular point. So you can go to the Anand Kumar book or Maurice Meno book. The detailed things are just study all the things very clearly. Then you can understand. And if any doubt, then next class, if you ask your doubt, then I will clear all the doubts. Okay, this is the advantage of digital systems. Okay, any doubt? Someone is any doubt? For a time right now you are facing some particular problem or concept is not clear for some particular points, then you can ask me, no problem. Any doubt?
No, sir.
Till now, no, sir.
Now the main thing is coming. Then what is the, see, everything are there are some particular advantage and disadvantage, but we are not directly say that this is the disadvantage. We are saying that limitation of digital techniques. So anyone can tell me computer or any particular competition machine, that particular machine understand what? Computer understand what?
Binary language. Zeros and ones.
Machine language.
Your answer is partially correct, not exactly correct. So why we are going very high funda? Don't use the machine language. Right now, machine language, yes, some particular topics are coming, compiler and something like that. That time, when machine language, assembly language, high level language, there are different type of language are there. But don't go to the machine. Just you remember, computer understand only 0 and 1. Are you getting my point?
Yes,
but
sir.
again, but someone is asking you 0 and 1. 0 and 1. What is 0 and 1? So 0 and 1 is not a normal number. Yes, in mathematics also we can use the 0 and 1. Yes, okay. But 0 and 1 is the binary number. 0 and 1 are binary number. Computer in this particular world, computational machine only understand two things, only 0 and 1. But when computer produce some particular output in the form of 0 and 1, that normal people, suppose in real world, people, the audience or people are understanding that particular 0 and 1. What is the meaning of 0 and 1? Yes or no?
No, sir.
No, because we don't know what is the that means 0 and the different type of sequence of 0 and 1, but we cannot extract what is the meaningful, and it is very difficult. We can extract, but it is very difficult. It is not a it is not a exactly provide the exact meaning. Okay, and it for a common people, it is very, for a common real world, it is very difficult. But whatever the output is generated from the analog system, we can easily understand. Suppose whatever is amplifiers, when the sound is produces that particular sound, when we are here that particular sound, then it is automatically we can understand. Okay, so whatever the output from the analog system, it is understandable in real world. So it is very meaningful information. The real world is analog. That is the main limitation of digital technique. See here, for competition purpose, for complexity purpose, we are using the digital circuit or digital system. At first, whatever some particular we are designing in the form of digital circuit, and again we are suppose digital technique. Again we are converting to the analog, and after that what happen, when the analog doing that particular interpretation, that time what happen, exact meaning is coming, which is understandable by the real world. Okay, so what happen, every output generated by the digital system always converted to the analog system. Are you getting my point? Because the output of digital system is not getting by the real world. So what happen? Some extra conversion is required, or when we are converting digital to analog to digital, or digital to analog, and again what happen, that particular digital to analog, some particular conversion process is required, or processing time is increased, or system complexity or more complex. That is the one type of limitation. But what happen, the people are ignoring this particular type of things, because we are only concentrate only the competition part. Are you getting my point? Any doubt here?
No, sir.
No, sir. No, sir.
Okay. So next, digital design of digital systems. Basically what happens, digital systems, there are three stages. One is called a system design, one is called a logic design, and one is called a circuit design. So first part, system design, it is beyond on this particular course, but some particular cases we are designing the system, we are also designing some particular system. But basically we are concentrated only two particular things. One is called a logic design and one is called a circuit design. But system design is high level abstraction, but low level abstraction is logic design and circuit design. Okay. So without logic design and circuit design, you cannot construct the system design. Now we are discussing one by one. What is system design? System design involves specifying the number and type of memory units and input-output device. Suppose when you can say that your laptop or your desktop is a one type of system. Okay. So there are different type of input-output device are there, memory units are there. Okay. So how their interconnection is with each other. So one particular subject, it is called a computer architecture, computer organization and architecture. That particular part, it is how the memories are connected and what type of input output device are connected with each other. That's all the interconnection and control of that particular subsystem is defined by the system design. Okay. So when we are designing some particular system, all the components, this particular memory units, input-output device, or some defined type of how they are establishing the connection with each other, how they are controlling with each other, all the things are described by the system design. That means system. Okay, that particular design process tell you how that particular component, which particular components is required at that particular moment, how they are connected, which particular components are giving the more priority to complete that particular task. All the things are clearly defined by the system. Now, next is what is logic design? Logic design involves determining how to interconnect basic logic building blocks to perform a specific function. Suppose what happen, I'm giving one example of logic design. An example of interconnection of logic gates and flip-flops required to perform binary addition. Suppose we are interested to performing one particular task that is called a binary addition. So when we are computing the binary addition, that time what happen? Some particular gates, some particular what happen? Logic gates are required, and to remembering the earlier state or remembering some particular things, the past events are also required. So what happen? We are using some particular flip-flops. So how we can connect and how we can design the building blocks between the logic gates and flip-flops logically, that particular part defined by the logic design or logic. So what happen when someone is asking you logic design means what? So different type of gates, how they are connected with each other, and what type of memory elements we can introduce with the logic gates. So different components we can establish together, and that is called a logic building blocks. That particular part defined by the logic design. Are you getting my point? Very silent.
Yes.
Okay. That is called a logic design. Now circuit design means what? Suppose when we are implementing the logic gates, there are different type of resistor, diodes, transistors are required to form a gate. So how they are systematically connected with each other? How many resistors we are using, how many diodes we are using, which particular transistor is required of that particular moment. Okay, and how we are designing the internal designing of flip-flops, that particular, all the things are involved in circuit design. So what happens when we are talking about the digital system, internally there are three type of stages are there. One is called a system design, it is the upper level logic design and circuit design. So when we are going bottom to top down approach, okay, that time what happens? Circuit design at first, after that logic design, after that system design. Are you getting my point? Are you getting my point?
So which one comes first, circuit design or system design?
Yeah. Yes, pardon, I'm not getting. Please tell me.
So which one comes first, circuit design or system design?
See here, circuit design is coming later. No, sorry, logic design, that means circuit design means what? At first, what type of, you can think about that, what type of things are actually required. Suppose what happen, you are using suppose two type of gates. Okay, so two type of gates, what? One type of gates is required, this type of terminal resistor, this type of diodes. So what happen, I'm using this type of resistor and this type of diodes. That time what happen, the combination of this one, that particular gate is formed. So that means at first what happen, if you are going to the low to high, that time what happen, you can know the information of resistor, diodes. That time what happen, after that you can design the logic design. But it is not important for you, that means which particular way you have to go. So at first what happen, this is not a that means what I mean to say, this is not a actually required, that means it is going to top down or bottom up. It is not a required actually. Okay, just you remember that system design, that means the three levels we are divided: system design, logic design and circuit design. Okay, and when we are logic design means what? To perform one particular task, suppose what happen, task means what? Some particular logic operation when we are considering, that time what happen, which type of logic components are required. When we are defining the logic components, that time what happen, the logic design is required. And when we are internally designing the logic components, which type of actually components are required. Specific components are required to design that particular logic design. Suppose resistor, diodes and transistor. When that particular concept is coming, that time what happen, it is called a circuit design. And combination of logic and circuit design, obviously what happen, we can design the we can system design. That means system means what? The standard for how many memory. That means you can say that what 3 particular circles are there. The upper circle is system design, lower circle is the logic design, and the low level circle is the circuit design. Are getting my point? Are getting my point?
Yes, yes, sir.
So it is not like that. Because all are interrelated with each other. System design also connected with logic design. Logic design also connected with circuit design. Again, what happened? This is the one particular flow, and if you are going the opposite flow, that way also circuit design also connected with the logic design, and logic design also connected the system design. That means it is one type of forming one type of circle. Both circle, anti-clockwise and clockwise, both circles are possible. Okay, but don't too much confuse. This is just you remember digital systems we are dividing in. That means we are complete in within the 3 stages. One is called a system design, one is called a logic design, and one is called a circuit design. That's all. Okay. So definition, what is system design? I have already discussed. What is the logic design? So if you are interested to know more, to know the details, just you go to the specific particular book, the first chapter, introduction chapter. Okay, you are getting that particular part. Okay, any other doubt? Any other doubt?
No, sir. No, sir.
No, sir.
This is the homework for you. This is the homework for you. So whatever we are discussing today, that means what we are discussing today. So objective of this particular course, outcome of this particular course, just we are comparing what is that means we are talking about the electronic circuit. Electronic circuit basically 2 types. One is called an analog circuit, one is called a digital circuit. Then what about the digital circuit and analog circuit? Okay, what is the advantages of digital circuit as compared to the analog? Okay, if you know the advantages of digital circuit, then you can automatically understand what is the disadvantage of analog circuit. Okay, and one particular point I am just this is the homework. Why information storage is easy in digital system. So whatever we are discussing, just I am writing in the question format. Okay, so this is the homework. It is not an assignment, but it's remember this particular part is very important. So you know the details, all those things. So what happen? You will study through the textbook. Okay, self-study is required, and also list out the advantage of digital system and briefly discuss all the points. Just I'm in the PPT. Just I'm providing the point. So you more elaborately, if you interested to know, then you can go to the textbook. Okay, and also it is for knowledge purpose. It is very required. Okay, so just you can download also from the net also. The maybe soft copy is available from Maurice Meno book. I don't know. So you just search digital system, digital circuit or systems. That particular book, right? Maurice Meno and plus PDF. Maybe some particular earlier version is coming. So, but introduction part is same for all the editions. It is no problem. Okay. Okay. Then again tomorrow our class will be started from 9 a.m. to 11 a.m. Tomorrow.
Yes, yes, sir.
Okay, and then okay, so today we are discussing this particular introductory part. Just remember this particular portion is very important for you. So first internal exam, again I am 23rd 09/2020, second internal exam 21st 10/2020, and third internal exam 25/11/2020. And the timing is according to the class timetable, and what is the syllabus, what are the syllabus, okay, and what are the paper format or exam format, that particular part I'll discuss later. I'll inform you later. Okay. Okay, then thank you very much.
Yes.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, thank you. Thank you. Good night.